Next, I'm going to go over the tissue layers. First is going to be the scrotal skin, which is the outer tissue, which you can't really see here very well, and it has low amounts of hair to help evaporative cooling. And it also contains temperature-sensitive neurons. So when it's exposed to heat, the neurons will fire to the brain, and this will activate the respiratory muscles and will result in panting, and the neurons also fire to the hypothalamus, which then activate the sweat glands, and this will help aid in the evaporative cooling process as well. And then under the scrotal skin, we have the tunica dartos muscle. So scrotal skin here is and then this muscle is located between the scrotal skin and the connective tissue. Just the outside here. And then this muscle contracts to reduce overall scrotal surface area or relaxes to increase overall scrotal surface area. And then it will relax the surface area to allow more heat to dissipate away from the testes. And this is what allows a testicle to be kept about 5 to 6 degrees Celsius below core body temperature. And when it contracts during physical activity, this is what protects the testes. And then under the dartos muscle, we have the vaginalis parietal layer. And then we have the tunica vaginalis visceral layer, which is basically this outside here. It's going to be the visceral layer. And then I cut into it a little bit here, but on the other side, it's kind of hard to see, but it's really small. The tunica albuginea, which is, I think somewhere around here. It's like right there. Okay, but this is the visceral layer, this whole outside here. And then next, you'll see the seminiferous tubules, which is orangish brownish tissue located outside the lobules. All right, and then which it actually contains the Sertoli cells, which are right along here. And then they're the site of sperm cell production and immature sperm cells at various stages of development. And then the seminiferous tubules will originate from these beta Sertoli cells that line the inside of the seminiferous tubules. This whole tissue is made up of the seminiferous tubules, making up about 90% of testicular weight. And in between these seminiferous tubules are the Leydig cells, similar to the interstitial compartments. And these surround blood vessel and lymphatic tissue, and that's important because they're the site of testosterone production. And then now we have the mediastinum, which is the a little bit lighter connective tissue, and it's the core of the testicle, which I believe is going to be this lighter stuff here. And it helps maintain its oblong shape. It provides structural support, and or else the testicle would be kind of long rather than a slender shape. But it also covers and protects tubular structures, which are referred to as REIT tubules, which we can't really see because they're covered by the mediastinum. But the REIT tubules carry sperm cells and secrete fluid from the seminiferous tubules to the efferent ducts, which the efferent ducts would be up here. The efferent ducts would be. And then, but the REIT tubules connect to the head of the epididymis. They're lined with ciliated and non-ciliated absorptive columnar cells, and they're surrounded by some smooth muscle, which is also important for contractions and moving that sperm cell along. Sperm will travel from the seminiferous tubules to the REIT tubules, hidden by this mediastinum, to the efferent ducts, which you can see then up into the head of the epididymis.